Okay, now in Proteus we are going to design the schematics for the ADC level project. So here new project. Okay, let's browse the perfect part for this. So PVG workspace. Here in ADC level, I'm going to create one small folder that is ADC simulation. Okay, so in this folder we are going to create our project. So here also I'm going to provide the same name ADC level. Done. Next, A4 size landscape we are going to use. No need to design the PCB. Finish. Now here we are going to take the controller that is STM32F103C8T6. Okay, okay. This C8. Okay, so we are going to select this one. Okay, in previous projects also in digital projects we have used the same controller. Now what we are going to do to simulate an analog source, what we are going to do, we are going to use one variable resistor. So click on parts. Here we are going to select the pot, that is a variable resistor. So pot dash HG. Okay, so this we are going to use. We are going to place it to the A0. Connect the variable wiper pin to A0. After that, using DC mode, select the DC source, place it over here, connect it to the first pin of your pot. After that, go to the terminal mode, select the ground pin, connect this ground pin to another terminal. Okay, our variable resistor is now going to work as an analog input. Okay, let's align it a little bit. Okay, this part is done. You can use 10K port also, no issues at all. Now with the ADC, what we have to do, we have to receive the data from the controller. In this case, what we are going to do, we are going for virtual terminal, and here I'm going to place it, right click, X mirror. Okay, now here our UART TX pin is PA2. This is our transmit pin. So this one is going to transmit and our virtual terminal is going to receive it. We are going to configure it for 9600. It is already configured for same. Now what we have to do, let's go for the hex file. So we drive PVG workspace, ADC level, debug, hex file. Let's open it, run it. Okay, now you can see that it is giving the value 0. Okay, whatever you do, it is not going to provide you the any of the numbers. Okay, now this is the huge problem in on internet also. You are not going to get the proper solution or guidance for this. The problem is with this STM32 IC. Okay, it is not properly or completely implemented in the Proteus. Okay, this IC is quite incomplete. Okay, if you want to see whether the problem is actually, you can go through the internal registers. There is a provision, but we are not going to do that right now. So let's delete this IC. Instead of this, what we are going to do, we are going to use another library, that is STM, or you can directly type BLUEPILL. Okay, so this BLUEPILL library is there. So we are going to use this. Okay, so there are two more, but you have to avoid these. These are just designed for PCB purposes. Okay, we are going to see this in the end of our sessions. Okay, so select this one. Okay, we are going to implement this and make the connections. So ADC to the PA0 and URT is PA2. Okay, this part is done. Now what we have to do again, same process. PC VG workspace 3, debug, and your hex. Open it. Okay, let's make it 8 megahertz. Okay, let's try this. Okay, it is not showing anything. Okay, there is one slight wiring mistake. So this should be PA2. Let's run this. Okay, now you are getting the proper levels for ADC. Okay, that this is what we want. Okay, now if you watch uh, the documentation and all thing of Proteus, you're not going to find the answer why that problem exists. But if you are proficient in Proteus, you can watch the register banks and you can kind of figure out that this the previous controller we are using was broken. Okay, now the ADC is of 12 bits, that is 2 raised to 12, that is 4096, that is 4096 steps in total from 0 to 4095. Okay, now we are just getting the number of steps. Okay, we are not able to find the voltage right now. Okay, we are just getting the steps only. So in next session what we are going to do, we are going to convert these steps into the voltage levels. Okay, yes. So in this video what you have to keep in mind, you have to use this blue pill, not STM32 F103 C8T6. Okay, we are not going to prefer this one.